roughly follow the headings. And we'll roughly follow the headings found in our paper. And so Margaret will start with the first section.
Thanks, Rene. So the first question that pops to mind is, what is this doing in an AI ethics talk, which is a lot easier to answer now than I thought it might be before I heard today's sessions. But really we're not addressing, it's an elephant in the room, the issues with algorithmic policing tools in general. I think enough ink has been spilled on that I don't have anything to add to it particularly. But when it comes to the ethical principle of proportionality, I think there is something to be said. And that is, there is ample evidence that there are harms that can accrue, particularly to disadvantaged populations from these tools, yet the evidence of them working is pretty scant. And there are probably a range of reasons for that, but our working hypothesis is that one of those reasons is resourcing, and that it should be possible to get a handle on what the resourcing demands are to improve the way these tools work in real life. So with that, maybe we'll go on to the next slide.
So Parkinson's law was introduced as an entertaining essay, and it was written in 1995 in The Economist. And the article starts with a statement that claims that work will expand to fill the time available for its completion. So this is based on two underlying concepts. We have the multiplication of subordinates and the multiplication of work. So when this law is applied to larger organizations, employee promotions can lead to hiring of additional subordinates, and subordinates can lead to more subordinates, and eventually there's an entire department to manage. So, however, the quality of the real world coming in from that department, i.e. the expanded structure now, may not increase very much, if at all, due to communication overhead and other factors. So in this essay, this got people thinking about how growth can lead to complexity and complexity to decay. So in this work, in our context of algorithmic policing, we wondered if algorithms served as additional virtual workers, filling in the role of humans and perhaps creating additional work as well. So according to a 2020 Citizen Lab report, there are three main categories of algorithmic policing technologies. The first two have a predictive component in them, and the third one provides sophisticated general surveillance and monitoring functions. The location-focused set of tools often tries to identify when and where criminal activity might occur. So one of the most popular examples of this software in a category is the PredPol system. The software is intended to help in the deployment of patrol officers. The next set of tools is the person-focused set of tools. And this is designed to identify individuals who are likely to be involved in future criminal activity, either as a perpetrator or as a victim. And one popular example of a tool in this category is the Chicago Police Department Strategic Subject List. This was used to target individuals for increased monitoring or other interventions. And they eventually stopped using this list because of reliability issues with the modeling results. Now, in the last set of tools, there's a range of technologies. And one example of a technology in this set of tools is the automated license plate recognition system that reads a set of license plates. And it enables the surveillance and profiling of vehicles through a collection of bulk data associated with these vehicles. And this technology is meant to improve road safety. And I'm not going to speak about secondary uses of these the data associated with these technologies, but you can imagine that that could happen. Machine learning touches many areas of life. Techniques are becoming increasingly complex, and despite the widespread adoption, there are transparency issues with the data and techniques. So in terms of AI model accuracy, so there are some considerations that might affect resourcing. So problems with data bias, they're well known. However, the data can change over time, so the distributions can change. And mitigation steps for this include like regularly retraining and updating models, evaluating the importance of new data. But updating models in production, that requires resources. And so that's also another consideration with our position paper here is, again, the theme of additional resources. In terms of data, here are some considerations that can also affect resourcing. So we have multiple different actors adding data to the policing system in various contexts. And so that challenges the data consistency in format, interpretation, and language. So resources are also required to tend to this data to ensure accuracy, consistency, and completeness in the data. So how does Parkinson's law relate to all of this? Well, by and large, the contribution of algorithmic policing tools is to add to the list of suspects and areas of concern. So more work. So adopting to these tools require additional resources in terms of officers and technical experts.
Thanks, Renee. So the paper itself works with data from the Chicago Police Department. And I just briefly wanted to say why we use that data. The first, which will be familiar to many of you, is it was available. That's not a small thing because we looked at about a 60-year period. So Chicago PD has made public some high-level data going back to the 1960s. Moreover, they are actually consistent in how they calculate some of these key measures. A lot of police departments seem to change how they do it every few years, which makes year-over-year comparisons quite difficult. So they had the data was available. They computed things fairly consistently. They have a long history of technology and new process adoption dating right back to the 1970s at least, and quite possibly earlier. So they're also a fairly dynamic department. And as most people who watch popular media know, they do have their crime issues. So they have been dealing with real challenges and there are things to report on. The upshot of all of this, and I've got a couple of slides on it, but the upshot is they have tried and they have tried and nothing seems to have made much of a difference. Can we get the next slide, Renee? So this slide is reflecting over time, so between 1965 and 2019, crime rates for murder and burglary. So what you're seeing at the top there, that sort of mid blue line there, starting near 100, that is the clearance rate for murders. So that's the rate at which murders were solved in the same year that they occurred. So you can see the police have been solving a lower and lower percentage of murders over the years. The next line down that starts around 40%, it's kind of navy blue, that's the same thing, the clearance rate for burglaries, in-year clearance. And then the other two lines are adjusted for population, murder and burglary absolutes. So I'll make 2 points. One is across the Western world, clearance rates are dropping. So I'm not saying that Chicago is unique in that at all. They are not. But basically, when you look across, you can see hotspot policing was adopted in 75. This is, of course, in 1975, not a computer mediated thing at all. It was based on expert knowledge of where there seemed to be a lot of criminal activity. Didn't seem to put a dent in murder or burglary. Then they computerized their records in the 80s. 2001, so we're kind of getting into the post 9/11 period now, getting into statistical crime analysis, and eventually this person-focused system, which was clearly algorithmic in 2012. Nothing seems to make any difference in terms of effectiveness or quality, if you want to look at it that way. Could I get the next slide, Renee? Just briefly, this is staffing over the same period. And what we've got here is total staff, so that includes civilians, and then sworn officers, and exempt staff are basically the captains and things like that. And again, you're seeing no real difference. So they're not realizing huge efficiencies. They're also not investing heavily. And one point I would make here is, in very broad terms, Chicago Police Department has approximately 15,000 people on staff, depends how when you look at it. And they have about 6 data entry clerks and 3 system analysts. and system analysts / programmers. So they're not heavily invested there. We did look through their contracts. It's hard to get enough clarity to be absolutely certain, but it certainly there was no evidence that they're investing heavily in contract support for this either. And next slide. So why is it that they adopt all of these tools and approaches and nothing seems to be making a difference? You know, we could talk about this all week, but our basic point is most of these sort of arguments do boil down to resources. They boil down to resources at different points in time, though. As Renee said, predictions require follow-up. That's human work. The data is known to be messy, let us say politely. You've got 15,000 different officers putting it in, 6 people to keep it clean. And then there are underlying socioeconomic issues that are not being addressed either. So where are the resources and what might the implications be? Could we get the next slide, Renee? So Renee discussed Parkinson's law. I'm circling back to that now, really just to say that what we wanted to do here was to understand what might be required from a resourcing perspective to meet that proportionality test. That is to enable these algorithms to succeed. We're not saying every algorithm is perfect, but if you don't give them a fighting chance, you can't even assess if there's a problem with the algorithm. So we wanted to put together and challenge this audience with a formula, a digital Parkinson's law, if you want to look at it that way, which might relate the resource requirements associated with policing with the factors on the ground that affect that. Could I get the next slide? So here you have it. And if you're really interested, please go through the paper. I can't do it justice right now, but essentially what we wanted to look at was, you've got to account for the amount of data that needs to be looked at and the complexity of that data. Obviously, surveillance algorithms are going to have different impacts than predictive algorithms, and probably even within prediction, there will be different classes of algorithms, so there has to be some accounting for that. What percentage of crimes are being solved in your community now? What percentage could you live with having solved? What percentage of crime is being reported? I should say here, you always have to choose a crime or an envelope of crimes because property crimes are very different than murder, for example. But what percentage of those are being solved? So we put this together as an invitation to others, especially if you are in a position to get good data, maybe work confidentially with police departments, to try to understand what the resourcing requirements are. Because right now, city managers have no way to sort of back up their claim that adopting these algorithms will require a resource input. And here is a sort of principle-based approach to that. And until they can do that, I'm not sure these algorithms will ever meet an ethical standard. Can I get the next slide?
All right, so we'll conclude. So in this work, we proposed the additional digital variant of Parkinson's law, extending the equation included in his original essay. Additionally, we put forward the position that algorithms can serve as additional virtual workers, filling in the role of humans and perhaps also creating additional tasks. So future work will include exploring basic interactions with the algorithmic policing domain, and by quantifying the mathematical relationships between the entities involved and validating or extending the proposed equation presented here.
Thanks, Renee, and thank you everyone for being here today. I would just make one more point, which is that media reports like to blame algorithms, and I think it is important that we widen out the responsibility for things like this when they fail and make sure that all factors, including resourcing factors, are being considered. Thank you.
Thank you, Margaret, and thank you, Renee. Anyone have questions? I do have a question. I also previously worked with some law enforcement units on developing different data mining techniques for them. So when I see that when I see them, that they're hiring. They are mainly hiring people to work on, let's say, some of the more recent topic like child pornographies. So even though they are increasing the number of people in the team, they may not be investing in murder case or other traditional cases, right? So would that be the reason that it doesn't help? I mean, introducing the computer tech may not help in solving those cases?
It could be. A few people have looked at specialized hiring, and hiring of highly skilled officers in an area usually does make a difference in that area. The problem is it tends to be a zero-sum game. Those officers have to come from somewhere, or at least their salaries take away the ability to do something else. So I wouldn't want to suggest that it never makes a difference. It's just that unless they actually make the pie bigger, all they're doing is starving one area to benefit another.
I see. Okay. Okay. Thank you. Again, any questions? No, Gabriel. Gabriel, sorry.
Hi, Margaret. Thanks for the talk. I was wondering, did the city of Chicago or the PD in Chicago have any involvement directly in this research?
No, they did not. This was entirely on public sector information.
Thanks. And that's what I was hoping to hear. But you did rely on data that was produced by Chicago PD, right?
Absolutely.
And I was wondering what you think about the reliability of that data, given some of the things that have been reported about Chicago PD, such as like black sites and downsampling of crime rates and stuff like that.
Yeah, I do not doubt that that kind of thing happens in some places, and Chicago could well be one of them. I started out just using murder because it's sort of hard to downsample murder. I added in burglary eventually just to get another marker. I suspect that does happen, and it's no one even going back to CompStat in New York that, what you measure is what you get in some places, but what you measure is what people avoid reporting in others. And that certainly does happen. I should say, actually, I should couch what I said before. Almost all the data came from City of Chicago and Chicago PD. A little bit of it came from the union, but it was the police union, but it was still publicly posted.
Okay, yeah, thank you. So we have to move on to the second presentation. So again, Margaret, are you going to present the next one, which is on AI transparencies in real-world context?
Yes, I will do that. And I'm just going to try to share my screen here. I was not hugely successful at that earlier. Can you see that okay?
Yep.
Okay, great. Thank you. So again, I think today has really, and the fabulous presentations we had today and yesterday, the last session with Professor Grossman and Mr. Justice Grims, have really set the stage for this and simplified my task enormously. The point of this talk really is to point out some of the serious disconnects between what Canadians think the law will provide if they need to fight an AI-enabled decision and what's actually likely to happen. And I did this work by looking through histories for people who have tried to fight algorithmic decisions that were not AI decisions in the past, because we have every reason to think that they will be treated the same. And for some reason, I'm having trouble advancing my slides. Okay, there we go. So that's the content. What do I mean by transparency? So this is primarily, I'm focusing on non-technical transparency. Obviously, explainable AI is a huge piece of the transparency puzzle, but where I think I can add value is around sort of the rest of those pieces. So I'm taking sort of the citizen's perspective, and you think of an individual who has been disadvantaged by an AI or algorithmic decision. That might be a tax assessment, or it might be a criminal charge or a sentencing recommendation or something like that. You know, what does transparency mean to them? Clearly, explainability is a piece of that. But looking back at this these historical cases, explainability wasn't actually an issue in most of them. And yet people still had a lot of trouble. There are questions about the mechanics of the decision. There are questions about the data, both, of course, the training data and the data used to develop the model, but also the individual data used in decision making. And then just the bases and assumptions that formed the original algorithm or system in the first place. And clearly there comes a point where if you can't get behind a decision and understand how it was made, there is a transparency problem that begins to undercut democracy, right? All right, I'm having trouble with my slides. So there are two ways to get access to records. And then I'm speaking from a Canadian context here, but it's, I believe, similar in a lot of Western countries. If you're up against a public institution, there are usually freedom of information or access to information laws that can help you out. The advantage to that is it's relatively fast, relatively cheap. The downside is there are a lot of restrictions, and I'll touch on a few of those later. The other case, which I'm not going to get into much because Professor Grossman and Mr. Justice Grimes talked about them yesterday, is if you find yourself in a court case, then you can usually get access to materials, or at least your attorney or your experts can get access to materials that are in the possession of the person on the other side of that case, and that are, you know, related in some way. The one exception I'll point out that they didn't get into last night is if something is relevant to the case in your opinion, but is not held by the other party. So let's say that you're facing a criminal charge. The other person in the courtroom is the prosecutor who represents the Crown. The prosecutor does not represent the police. So if something is in the possession of the police, the only way you can get access to it is to prove that it will be relevant to your case before you have been able to see what it is, which can be enormously difficult and leads to a couple of the recommendations for this community that I have at the end. So I mentioned that there are challenges in freedom of information. Outside of Ontario, freedom of information does not apply to software. So if you're fighting an algorithm embedded in code in one way or another, and you file a freedom of information request to try to understand how that algorithm is working, even if it's completely explainable, you will not even get to first base with your request because it's just not in the scope of the legislation. In Ontario, so far, they have been treating software as if it's in scope, but it's still really, really hard to get access. And some of these reasons were described last night. Things that are confidential, business information, this type of thing, tend to be excluded. And there's really no middle ground here. Whereas in court, Mr. Justice Grims explained how you can have an independent expert who's kind of sworn to confidentiality, they can go through it. That doesn't exist in the freedom of information context right now. And I'm going to skip courts because it was discussed yesterday. So what would it take to actually have a system that makes sense? And there's been a lot of talk today. My heart is full. There's been a lot of talk about, you know, how we can put in, you know, parameters, structures, etc., to make AI safer for people. Well, of course, explainability is a huge piece of that. I'm not discounting it. It's just not where I can add value. But independent reviews of systems and the data that goes into them, open publication of the resulting reports with appropriate redaction where genuinely necessary to protect commercial interests. And then independent tribunals. So if, you know, let's say you're fighting a finding from an audit, you know, and you feel that there is something deeply wrong in the algorithm, you can ask the tribunal to investigate, and they have the experts to do that, and they're able to get at the confidential information, sort of akin to the way Mr. Justice Grims was explaining happens in the court context. And then secondarily, the ability for them to issue remedies and penalties. Because, you know, if AI is going to take over most of the important functions in society, it's also going to take over most of the trivial ones. But at some point, you wind up with death by 1,000 cuts, right? It may not be a life-altering decision, but if it costs you $200 over and over, and it's costing a whole demographic $200 every 6 months, and it's wrong, there needs to be a way to stop it. And the way to stop that usually is with penalties, because nobody's going to sue for $200. So how do we make this feasible? How do we make this work? This figure is kind of a lot. I don't expect you to absorb it all, but I put it here to give you some kind of flavor. On the left-hand side of your screen, and I'm not sure if you can see my cursor, but on the left-hand side of the screen is sort of utter transparency. So everything's open source, the data is open, you can see everything. This is great for transparency. It blows up the business model for a huge number of software vendors, and therefore would have some deep implications and costs we may not be willing to pay. On the far right, we have the case where there is no accessibility whatsoever. It's a complete black box. You simply accept what you're told, pay your penalties, and go on. And this, of course, has a lot of implications. It's incredibly corrosive to democracy and human rights. Everywhere in the mushy middle is kind of where people are thinking and trying to do some work today. And I've got arrows that for whatever reason the text doesn't seem to be showing up, but on the top, there are only 2 arrows on the top, and the one on the left-hand side of the top is reflective of the general opinion voiced by Ontario residents who were consulted last year by the Ontario government on what they wanted to see around AI transparency. So what they said was they understood that, you know, it can't be completely open, but at the same time, there should be a lot of transparency and a way to have humans look at these things and assess. These other arrows reflect different legislative positions, or in most cases, they're not actual legislation, they're pending recommendations. But if I just take a second and point to the middle box here, these are items that you can add or subtract, add a little more of or a little less of if you're a government, to move the needle between openness and closed to match the needs of your society and their reasonable expectations. Okay, and I think, oh, okay, well, here you go. So that's the identity of all of those pieces of legislation. I should say, I don't think the US Act will pass. It didn't pass last time, but I think the EU regulations will pass in some form or another. But Canada's way over on the right now. So, transparency's toeholds. What can you actually do right now? How can you as AI experts help? So I mentioned that, you know, a lot of times people have to prove something's relevant before they've seen it. They need to be able to raise kind of doubts about the veracity of a model. So if you know there are issues, you know, obviously you've got to be careful about not being sued, but provided you can back it up, publish that, because people who are fighting these systems going back 20 years have been relying on publications to say, look, there's a problem, you've got to let us dig deeper. Also, firms that are claiming that their entire software package is confidential, which they often do, generally aren't acknowledging that there's often open source and other common code elements in there. So if you are in any way involved with open source licensing, let's try to push acknowledgement for open source when it's used, and also traceability to the extent that's feasible. And then finally, just be heard. You know, the Ontario government consulted. I wonder how many of the people on this call who are in Ontario participated in that. Their transparency GitHub site is still open and still accepting some comments for their framework. Be heard, be out there, be engaged. Thank you very much.
Yep, thank you again. Any question from the audience? Yeah, I also have a question. So because some of the information that developed in the government. Okay, first of all, Canada is a free country, right? So we live in a free society. We have a democratic systems, but in the world, there are some other countries that do not share the same value, and some of the foreign state government, they may take this advantage as a way to access our secrecies, which is quite important for national defense in some cases. So we need to have a certain balance between national security and the freedom of access, right? So do you have any comments on this subject?
Yes, so technical secrets are one of the things that don't fall within freedom of information. You'd have to pull up each individual act to get the exact list of exclusions, but so I'm from the National Research Council. We have people that work on papers, they do research. None of that is accessible through access to information, right? Well, the published paper, yes, but you don't need us at that point. You can just, get it from the publisher. So there are exclusions. And I'm not saying that a lot of these exclusions aren't valid. I'm saying that sometimes they're abused. And we need, in an age when the people trying to get access usually don't have a deep knowledge, for example, of AI, we need to pave the path for them with information on known failures in these systems, so that they have a fighting chance, or their lawyer has a fighting chance of being able to identify and call the right expert.
Okay. Any other questions? Okay, thank you very much. Thank you, Margaret, again. Thank you.
Thank you.
Yeah. So we will move on to the third presentation. I think it's by Chu Fei. Yeah. So yeah, you can start whenever you're ready. So the topic is evaluating explanation correctness in legal decision making.
Yes.
Yeah. Okay. Go ahead. Yeah.
Okay, cool. Hello, my name is Chu Fei, and today I will be talking about evaluating explanation correctness in legal decision making, as Benjamin just introduced. This paper was written in collaboration with Rohan, a PhD candidate from the ECE department, Professor DeHaan from the Queen's Law and Conflict Analytics Lab, and Professor Zhu, also from the ECE department. So today I'll be going over the background and motivations of the paper, our key methodology, which is just definitions and metrics, results, and then the conclusions that we can draw. So first, from an engineering perspective, it's important to involve the end user in evaluating any solution we design, not just in AI. This is especially true in high-stakes domains such as law, medicine, and finance, which require specialized knowledge that isn't easily accessible outside of those domains. From a previous study, lawyers in particular said they expect their tools to have fairness, lack of bias, transparency in the decision process, and consequence awareness. This hasn't been a priority in the latest advancements in machine learning, from ensemble methods like gradient boosted decision trees to large language models like GPT-3. And so in contrast to the previous talk, this is more focusing on explainable AI and how it can be used in tools used by lawyers, as opposed to like AI algorithms that show up in courts. So within the XAI community, there are two main types of methods, anti-hoc versus post-hoc. Anti-hoc covers anything that is designed into or trained with the model. So in the example on this slide, we are trying to predict the label of confusion versus no confusion from a trademarks dispute case. If we were to go straight from the text to a label, like a typical NLP task, this wouldn't satisfy transparency in the decision-making process. So an anti-hoc solution would be to train the model to predict intermediate labels. And a lawyer specialized in trademarks would be able to reason the outcome from these intermediate labels, making it easier for them to interpret the final outcome. Conversely, post hoc methods are those that only are used on a fully trained model. The most popular subtype is feature attribution, where the method tries to measure the contribution of each input feature to the model's output with something like this. This image shows tabular data, but this could also work with any type of data, such as text or image. We are focusing on evaluating post hoc methods. Due to their many advantages, they are easy to understand and generalize, and they are model agnostic, so they can work with any task, any data. This is practical for industry integration, where there are many black box models and deployment that may be too expensive to redesign. Post hoc methods are therefore a good choice for quick integration. However, the issue is that they are more generic than anti-hoc designs. So going back to the frame of a high stakes problem where it is working with highly specialized knowledge in the model, are post hoc methods sufficient for every task? And are the outputs accurate for every data set? And this hasn't really been explored in legal tasks. So we wanted to conduct a thorough evaluation of post hoc methods. We're using tabular data over text or image for a number of reasons. Mainly, we had access to lawyers who designed like tabular tasks and tabular data sets. And so they understood the model inputs and are aware of how they contribute to the final decision. So the evaluation is purely on how the explanation is reasoning over the contributions of each input feature, rather than how the model abstracts, say, a long legal document. It's still possible to evaluate post hoc methods on text or image data, but tabular is a clearer comparison of the methods themselves for our purposes. Since we had access to the lawyers that designed the tasks, they have extensive knowledge of the case law and good intuitions for how much an input contributes to the outcome. So we asked them to participate in our experiments, which provides valuable insights. And then finally, the evaluation framework can be extended to any field or discipline. And so hopefully the methods that we are using today are helpful regardless of your specific problem. And so we are looking at 3 legal decision-making tasks from different areas of law: personal injury, trademarks disputes, and employment worker classification. Each of these require their own specialized knowledge and are generally a good distribution of legal problems, excluding criminal law. The tabular data was curated by the Queen's Conflict Analytics Lab. And for the model, we are using XGBoost, which is a gradient boosted decision tree that's the current state of the art on tabular data. And so we are evaluating 2 popular post hoc methods, LIME and SHAP. These have open source libraries, and so they are the most convenient to apply in a practical setting. I won't go into the details of the algorithms, but they both perform feature attribution and they are both model agnostic. And so for evaluation criteria, how are we determining whether an explanation is good or not? There are many emerging qualities of a high quality explanation, including correctness, robustness, and simulatability. We're focusing on explanation correctness evaluated in two components based on previous work. So the first is plausibility, or how sensible an explanation is to a human, and faithfulness, how closely the method reflects the original model. And we split it into two like this because the two components require different types of evaluation. So a human can't say what's accurate to the original model, and a model can't say what's correct to a human. So for faithfulness, we measure it with model appellations, a metric known as diff AUC from a previous work. For a global feature ranking, we remove the features in order of importance, then retrain the model and plot the F1. And then we compare the area under the curve of that plot to a random ablation. And a negative score on this metric would be better. For plausibility, we essentially want a negative correlation between model error and explanation quality. So like intuitively, the more wrong the model is, like the higher the error, the less sense the explanation should make. This is a metric which, compared to existing work, it doesn't rely on other XAI methods as some secondary label. So we are only using the error and rating of the explanation quality, which would ideally be found from a user study. And then for the user study, we evaluate the subjectivity or bias with these two inter-rater agreements, just to make sure that the data is sound. And then here are our results. For faithfulness, we found that all the methods outperformed the random baseline, which is in red in these plots. And so each of these feature attribution methods performs pretty well, but between Lime, SHAP, and GAIN, which is XGBoost's model-specific feature importance, there isn't a clear winner across our three tasks. If I just wanted to look at these three, I might say that there's some nonlinear dependence between the number of features and faithfulness, but in general, it seems to be dependent on the task, and we might need more testing to have a clear conclusion here. And then for the user study, we asked the lawyers to give a rating of the explanation, and then some comments on which specific features of the input felt inaccurate. And so this is a more stable rating of subjectivity than like just looking at the rating itself, as we found that participants had like slightly different standards of quality. And so we found that for plausibility, regardless of subjectivity from the user study, the SHAP method performs better than Lime in all cases. And so, yes, we have reached the conclusion today. I have shown a two-part evaluation format for evaluating post hoc for any explanation correctness, which can be applied to fields outside of law. In general, the evaluations showed inconsistencies in faithfulness, although like if I had to say one is more correct, then probably SHAP is more plausible. However, the inconsistencies emphasize the need to evaluate different tasks individually, even with a method that's claims to be model agnostic. And it is also important to involve the experts from different domains and make use of their expertise to make sure that the evaluation is grounded in domain-specific knowledge. And that's it for my talk. Thank you.
Yep, thank you, Chu Fei. Again, any question? Yeah, so you mentioned about the it's a post hoc XAI, right? So let me just understand it correctly. So it means that you have a model that make the predictions, and then you have another way to try to kind of mimic the reasoning. Am I right? So if it's in other contexts, that seems to be fine to use a post hoc XAI. But if it's a legal cases, then how can you guarantee the explanation actually corresponds to the actual predictions, right? Let's say I predict something that is in class A, and we try to mimic that explanation. It's not the actual reason. It may not be the exact reason being used in the predictions, right? So how can you make sure that they are actually correct? Yeah, go ahead.
Yeah, no worries. Yes, it is by definition of the explanation method. They are by design required to be as close to the original model as possible. So they, for the most part, are based on how the model's output changes with respect to the input. You have one example of a case, and then you use the model in inference mode to like predict an output. And then you change that input slightly, take the output again. And then change kind of shows the impacts of like the specific feature. So again, it is an approximation, and there have been other papers that dive deeper into like specific issues around that approximation, but it's to their best efforts, as close to the original model as possible.
Okay, but we can only guarantee the input output are similar, right? The output are similar, but there may be different path, different reason to achieve the same conclusion. So would that be possible that in the actual classifier, when we make the predictions, we have some combination of reason leading to that conclusion, but in the XAI path, we actually have another combination of reason that may not actually correspond to the actual predictions? Would that be possible? We will run into that situation.
It's definitely possible, although that would be a flaw in the design of the algorithm.
Okay. See, this is very interesting. Thank you. Does anyone have any questions? I shouldn't be the one only asking all the questions. Okay. Yeah. And then that's thank you very much. Thank you, Chu Fei, again. Thank you.
Thank you very much.
Yeah. Okay. So Matab.
Yes.
So, yeah. So whenever you're ready, you can make a share your screen.
Just give me a second, please.
Yeah.
Can you see my screen?
Yeah.
Okay, great. So, so hello everyone. Thank you so much for your attendance to my presentation. My name is Mahtab Sarfmili, and I'm PhD student at Dalhousie University. Today, I will be presenting my recently published paper at Canadian AI, which is called Bqe, a modularized framework for explaining black box classifiers for text data. And this work has been done with the help of a researcher from the University of Memorial University and University of Pisa. The main points I will cover today are as follows. First, I will explain about the objectives and the motivation of this research. Then I will talk about the structure of the data and its components. And after that, I will present the experimental result. And finally, the future plan for this research. In recent years, we have seen a drastic rise in the application of complex black box models such as deep neural networks, or even more complex models for natural language problems such as sentimental analysis, text classification, text summarization, etc. Although they have gained outstanding performance, they still remain a mysterious black box for the user. We use the black box term because we don't understand how the classifier really works and make the prediction. And the internal processing remain hidden with respect to the outside user. Also, since 2016, a new regulation has been constituted, which is called the General Data Protection Regulation, that requires authorities to provide understandable explanation if any critical decision-making involves human user. In addition to the ethics of AI, understanding the behavior of our model, we can make sure that the decisions that are made by the black box is valid and the training process or the prediction process makes sense. For explaining sorry, I should mention one thing, that in this research we have mainly focused on the text data because with regard to tabular data and image data, there has been a tremendous work, but the text data that works on text data is a bit limited. So we mainly focus on text data in our research. For explaining the behavior of black box models, various types of black box explanation algorithm exist, but from a top-level point of perspective, they are categorized as model-specific versus model-agnostic, and local versus global. An agnostic predictor is not tied to a special type of black box or data type, and it can be applied on varieties of black boxes and data types. However, due to the limited number of the fully agnostic predictors, since the principal task is the explanation of the black box, we refer to the data-specific models and agnostic explainer. Also, locally understandable or a local explainer, they try to understand the behavior of the black box model for a given data instance. With respect to the global models, which is called the global explainer, it's not the global explainer, actually those explainer or those models are globally explainable for every data instance. In another term, they can be called as white boxes. So based on our observation, we were trying to design a framework that can be applied to various types of models, text classifiers that can locally explain the behavior of a black box. And it should be simple, understandable, and transparent. And also use some intuition of natural language for explaining the behavior of the black box. What we had in mind for this framework is the way that we understand the decision of each other on a special matter. For example, if I want to understand someone's opinion about a specific topic, I will try to ask similar question, and based on the observed answer, we can explain how the person reacts in that specific situation. So in this case, it means like we are trying to create a similar situations, and then based on the behavior of the model in those similar situations, we can make the prediction that how it behaves in a specific condition. So here's the framework of dicta. We have designed dicta as a modular, model agnostic text explainer that uses the word net for creating the neighborhood. Since replacing the words with their synonyms and antonyms can create similar or opposed example, we decided to employ WordNet for this purpose. A WordNet is a strong lexical database that keeps the same set of words and their semantic relation. We try to create semantically similar examples using the words synset. In the first step, after the training of the black box model, in order to explain its behavior, for a test example, we pass the given document to the model, and the framework measures the class probability of that instance. The second step, a dicta searches for the topmost informative sentences in that document. The informative sentences are those with the higher importance on the class probability of an instance. So by eliminating the sentences one by one and measuring the change on the prediction probability, we can find these sentences. Since these sentences contain more critical words that define the class label of an instance, replacing them with the sin set will create semantically similar examples. In the third step, the neighborhood generator replaces the words of informative sentences with their semantic set and create a set of similar documents. Then it passes this generated document to the black box for the labeling of the neighborhood data. And then after getting the labels and the generated neighborhood, it passes the framework passes the data to the interpretable model and uses them for training the interpretable model, which in our case we use the decision tree. And finally, we can extract the feature importances using the outcome of this decision tree. Here I will present the experimental analysis of dicta. To evaluate our model, we have examined its performance on 4 sentiment analysis benchmark dataset, Yelp business reviews, Amazon product reviews regarding clothing, shoes, and jewelry, tweets related to US airline, and IMDb movie reviews. The details of each dataset is given in this table. To ensure that our model is not dependent to a specific type of black box model, we have tested on 3 different text classifiers. First, BiLSTM and BiGRU are two recurrent model that takes advantage of 2 layers of bidirectional LSTM and bidirectional LSTM and GRU, respectively, which is followed by a dense and a softmax layer. Also, we have tested the model on a convolutional neural network that's used for the text classification, and the same structures following the paper by Kim that was published on 2014. And finally, we have tested on the random forest with 150 decision trees. First, we have evaluated the fidelity of our model with respect to the black box predictions for all data. Fidelity is the faithfulness of the interpretable model to the prediction of the black box model in the predicting the class labels of a neighborhood data. So in this case, the y-axis shows the accuracy of the model in predicting the class labels of the neighborhood data. And we conducted this experiment for all different data, for our 4 data sets and for the different classifiers. And we compared our model with respect to line. And the green boxes represent the performance of dicta, and the blue boxes represent the fidelity of line. In order to ensure that the obtained results are solid and statistically significant from the fidelity of line, we have conducted a statistical test, Wilcoxon test, and we reported the p-values of the Wilcoxon test in this table. So based on the obtained result, it proves that the fidelity of dicta is statistically significant than line. Here we have outlined the outcome of dicta on an example of airline tweet, and in this figure you can see the comparison between the dicta's performance with respect to line and SHAP. The call outs shows the sin set that the words were replaced with them, and the positive and negative impact of them on the classification of data is shown with different colors and different intensities. The green and red shades of color are for the positive and negative impacts of the word on the class label of this instance. Another analysis that we conducted was qualitative evaluation of the decision rules. We linearized the decision tree into a rule form. Rules can be extracted from the decision tree by tracing down a decision path from the root node to the leaf node. An example of a trained decision tree and traversing it from an instance of the Yelp review is given in this figure. Since we are using the TF-IDF vectors for training decision tree, the real value at each vector is compared to translate the importance of that word net in the neighborhood of the training set. And also, similar to the previous slide, the callouts are showing the synth set that the words were replaced with them. Finally, we have conducted an experiment to compare the salient scores of words with their sentimental polarity extracted from a sentiment lexicon. For this purpose, we first binarized the class labels into positive and negative. Then, for each of the words, we extracted their sentiment by tracing the decision tree, and we had to binarize the sentiments of those words as well. And then we conducted an experiment between the line, shap, and dicta. And we reported the result in this table. As a discussion, or to summarize the whole research, is that the choice of the word net for neighborhood generation benefits from the simplicity, transparency, and understandability. And the word net is also available for all of the in so many languages, and a similar concept can be also found for other domains, such as the medical text or other aspects that we're looking for. So we have this ability to replace each one of the module of the WordNet with something similar, and we apply this framework for another domain. And so also in the future plan, we can incorporate other lexical databases such as medical trusses or urban dictionary to enrich the neighborhood generation. As a part of the future plan, we are planning to apply human evaluation studies and employing this model for explaining more complex black boxes such as transformer. And so that's it. Thank you so much for your attention. I appreciate all of your comments and thoughts on this.
Thank you very much. Thank you, Mahtab. Thank you. So, and again, any questions from the audience? Yeah. I have a question. So you use WordNet, right? So WordNet has different, for every word it has different synonym sets, right? So-called syn set, if I remember correctly. So how do you choose, given a word, how can you choose which syn set I should use?
So I chose the synonyms, the antonyms, and hypernyms and hyponyms, because when I tried to only apply the synonym and antonym, the number of the generated neighborhood was not enough to fully explore the neighborhood area, and I had to increase the randomness and also employ more features to enrich the neighborhood. So as I said, I used the synonym, antonyms, and hypernyms and hyponyms. And the selection between them also was random, because if I wanted to favor one with respect to other, for example, if I wanted to favor like synonyms with respect to hyponyms, the randomness or the density of the generated class labels wouldn't be that much. That covers, like, have a really good coverage over the neighborhood, and also like covers all of the classes that want to train the interpretable model.
I see. But even for each, let's say for the synonym, right? If I remember correctly, for every word they have multiple synonyms. They have multiple sets of synonyms. Depending on different context, they may have different synonym, right? Let's say the word window, right? It can be window, door, renovations, right? That is one context. It can be windows, Microsoft, right, Macintosh. So we can talk about operating system. So in different contexts, they have different synonym sets. So in your method, do you have to choose a specific? How do you choose which context I should use?
So basically, I usually favor the first, like in our framework, we try to favor the first, which is like more meaningful, which is closer to the word. In case if it's like they had a lot of the synonyms and the generated neighborhood didn't provide like a good coverage over the class labels, we had to go and try a different synonyms. I understand that there was some cases that the examples or the synonym was not correctly into the correct context of the given text, but in order to keep the diversity, we had to risk it for few examples to keep the higher diversity, because it might happen, but for most of the cases, as I said, to keep the diversity in the generated neighborhood, we were forced to select randomly between, select more than one synonyms.
I see.
Yes.
Okay, yeah. So the Roberta or some transformer method that put the context in there may help address this issue.
Yes, yes. I was planning to go deeper and like bring this intuition of using the context for this. So this can be another step for the future of this research.
Yeah, thank you. So any other questions? Thank you very much. Thank you, Marta. So the next one is Shannon. Shannon, are you ready to give a presentation? Okay.
Sure. Let me share my screen.
And yes, sir. So you will be the next one presenting. Thank you.
Great, that works. Everyone can see that?
Yep, perfect.
I'll start a timer too, so I don't go on too long. Hi, my name is Shannon Davidson, and oops, I just went for it. I'm the R&D director at Advanced Symbolics, which is a company that does behavior and opinion research on the public. So basically, it's kind of like a polling company, right? The people who kind of, and during an election, for example, say like, what percent of the population they think is going to vote for whatever party, and polling companies do that by calling up a bunch of people or using internet polls. What our company does is, instead of doing that, we use public data like social media and artificial intelligence tools to kind of generate data, kind of like a poll, to generate kind of what the public is thinking about various issues, or to do market research. This work was also done with Vaibhav Kesarwani, who's a machine learning engineer at Novacine AI, which is a company that creates machine learning solutions for various customers and their data. And also work was done by Kenton White, who's also at Advanced Symbolics. So actually, before I jump in, since this is the ethics kind of panel, I was going to try to kind of relate, because the bulk of this presentation isn't about ethics, but there are some ethical considerations for kind of work. So I'll just give a brief anecdote. Like last night or yesterday, for those who are in Ontario may know, there was an election in Ontario. And so as a company that does, kind of election polling, we were involved in them. A bit tired actually today, because we were on Ontario's public broadcaster last night, providing kind of color for their election show as the results were coming in. And this election, we had said previously that basically was guaranteed, more or less, that statistically that the progressive conservatives were going to win. And a lot of other people, this was pretty common too. I think this is what most polling companies were saying. And so when the election results came in, they turned out indeed to be a large majority for the progressive conservatives. Great, so we're right. But the other interesting thing about this election is it has had by far the lowest turnout in Ontario history, like record low turnout, especially by people who, the opposition parties, right? The parties who would be people voting basically against progressive conservatives. And so I think a reasonable hypothesis for one of the reasons that might be is because all the polling companies out there, including us, were saying like, okay, it's guaranteed that the conservatives are going to win anyways. And so I think it's very possible that a lot of people just decided, you know, well, if the conservatives are going to win interviews, what's the point of even going out and voting? So there can be those kind of repercussions when you're informing the public about political issues that you really do have to kind of take into consideration, because, you know, our job is not to try to influence political choices, right? It's to inform the public. Although I should say maybe it's not our fault, because there's also a theory out that just says people get election fatigue when you have too many elections in a row, which can bring us to the election that this is about, the election that maybe gave everyone election fatigue before the Ontario's election, which is the federal election of 2021. So this paper is on forecasting and understanding the 2021 Canadian federal election using Twitter conversations. So let me just start by kind of, to begin with, I just want to show some progress, because I was here 2 years ago with another paper that was forecasting city council in the 2019 Canadian federal election using Twitter, speaking of election fatigue. And now we're back 2 years later with a paper on the new election, but also now it's forecasting and understanding the 2021 Canadian federal election using Twitter conversations. So we have made some progress in what we're doing, and that we're now trying to not just predict things, but actually understand why they are. And I think that's kind of a pretty exciting thing. So to give some background on this particular election and what we were trying to do, in this election, the Liberal Party, so it's going to be red color whenever you see them, because that's their part. That's the party's color. The Liberals were in government. They were in what's called a minority government, which means that at any time, theoretically, the opposition parties could all gang up on them and force an election. So in those scenarios, you probably want to call an election when you think it's convenient for you, so you can maybe win and get a majority and not have to worry about the opposition parties kind of ganging up on you. And so it happened that in the summer, according to public opinion polls in general, the Liberals were doing very, very, very well. Everyone was, I guess, kind of happy with how COVID had gone. And so they said, okay, here's our chance, we'll call an election. And then they called an election, and basically there wasn't really any issues about it that seemed to come up in the campaign. But nonetheless, actually, the polling, so I know this is messy, I'm trying to show you all the polls so you can see kind of how noisy actually public opinion polls really are. But you can still see general trends, right? Like the blue, the Conservatives kind of actually at some point actually ended up ahead, right? And then by the end, it kind of went back down, and the Liberals ended up squeaking out like another minority government, and basically nothing changed. And so over here, I've actually done a low S so you can see, because this is why you don't want to trust one polls, because you can see like they're noisy as heck, right? But if all the polls are kind of agreeing on some general trends, you can probably trust. So I do believe, I don't believe every single up and down here, but I do believe that in fact, right, probably the Conservatives were ahead at some point, and in the end, this kind of went back to here. And so first of all, so what we want to do is we want to be able to make this kind of data ourselves, but using social media, right? Be able to kind of see, not just at a moment, but a time series of right, who's kind of ahead in the polls. And also our goal is hopefully to be able to understand why we see changes. So for example, like clearly a change did happen here, right? There was a big change. It's like, well, why did that happen? And I should say like pundits were kind of unclear themselves. Like there wasn't really a general consensus of why this change happened, because again, like there didn't seem to be a lot of issues, and yet suddenly the public seemed really angry at the Liberals when they were so happy about them before. So let's just say, so the data that I'm using is Twitter data. So I won't go to the details, but we have a sample at our company so that we don't just grab from all the Twitter data from Twitter. We have a sample of about 300,000 Canadians when we're doing Canadian work. And I'm grabbing tweets from Twitter, from our Twitter sample about the parties. And so here's so I'm looking for on a given day, and I grab them every day. So every day I'm going to look for, okay, what are all the tweets in our Twitter sample that mention, Trudeau or Justin Trudeau, the Liberal Party, blah, blah, blah. And just to give you a flavor of kind of what they look like. This is kind of just me showing how many tweets we have per day in these samples. You can see that like the Liberals are always number one. And it speaks because they're in government, right? So people spend a lot of time complaining about government. And so who's ever in government is going to be the party that has the most tweets probably. There's like a spike here. That's when the debates happened. So people talking more about the politics on that particular day because there's, a show on TV that kind of focuses people's attention. Now to get like opinion polls from this, like, well, one thing that, for example, it's been done in the past, people think, well, maybe we'll just use the magnitude of Twitter and say like whatever party has more tweets about them, they're probably going to be the most popular party. And I believe that did work for one particular German election, maybe 10 years ago. But in general, obviously, that's not a great strategy. A more common thing is to say, well, maybe I'll try to use like sentiment and say like, well, a Liberal tweet that has positive sentiment, I'm going to assume is the user saying they like the Liberals, and one that has negative sentiment, I'm going to assume it means they don't like the Liberals. But in general, that also tends to not work great. Sentiment, if anyone's dealt with, for example, Twitter data before, probably knows like it's hard to really interpret what sentiment means. And in political data, that's like extra true. The way people talk about politics is very kind of convoluted and ironic, and kind of involves, you really have to know the context of what's exactly being said. Sometimes even like a human cannot tell what direction the opinion is going in a tweet, because it probably is being ironic about some other tweet that happened before. So you can't really use any kind of simple metric to determine whether a tweet is pro or anti someone. So the way we try to get around that is we try to not actually deal with individual tweets at all. What we try to do is deal in conversations. So I'll explain that on the next slide. Yeah. So what we want to do is, instead of having a single tweet, on every day, I'm going to try to cluster tweets together that are the same, quote unquote, the same. And I'm going to consider that a conversation. And then I'm going to try to use that as my unit of analysis. So in this, I'll just briefly explain how we actually say what tweets are similar to each other. So we're using, so for a given day, right, I have all my tweets on one day that about the liberals, let's say. Then I convert all the tweets to vectors using BERT. So BERT, for those, I don't know, unfamiliar with NLP. So BERT is a language model, which let me explain, because it's basically a giant neural net that's been trained on, like, all of Wikipedia and a bunch of the internet by Google. Google makes a very nice data set that's huge. And they train a neural net, and they train it using this little game where you like kind of hide, you give it a sentence, but you hide a word, and the neural net has to guess what word should have been there, right? So by training it on this game of being able to kind of identify what word should have been somewhere in a sentence, called masking, you hope that this neural net's kind of learning just about English in general. And then you can then use this big neural net that knows hopefully English in general. You can fine tune it on a particular task that you're interested in. Right now, you maybe have some label data, something to say true or false or whatever, but it already knows English, so you don't have to give it too much more data. We're using a way where we use that structure to grab a vector out from kind of the innards of kind of the same way you do with word embeddings, but for a whole sentence, or in this case, a whole tweet, right? So I'm going to get a whole vector for each of my tweets. The vector is has a dimension of 200 and something. And then once I have vectors for my tweets, then I can hope to cluster them, because now I know how similar they are. I can measure how far away my tweets are from each other. Although, of course, there's now many ways to cluster vectors. And so in our case, well, specifically, actually, Bqe Ltr figured out that the way that seemed to work the best was using a kind of a customized kind of multi-pass of density. It's a version of DBS scan, which is like a density-based filter. Again, intuitively, basically, you pick a distance, and then all the tweets that are kind of close within that distance from each other, you kind of cluster together. And then in this case, we do that iteratively many times, and that seems to work with the right kind of parameters. Now, notice an interesting thing about doing it this way is that you will get tweets that aren't necessarily in a cluster at all, right? So if you're not close enough to anybody else, you're just kind of out there in space, and you're not in any of our clusters. And so just I'm just giving kind of example of like the results I get, right? So I would give like this tweet's not probably more like 10,000 tweets, right? But I have like 10,000 tweets, right? And then I'd get back, once I run this clustering, this vectorization and this clustering, I get back, depending, these are 4 resolutions, which mean just 4 set of hyperparameters I'm using. And so, for example, here I have like these 2 tweets happen to be in the same cluster, cluster 1. If I do a different hyperparameter, right, actually all 3 of these tweets are in the same cluster. 1,000 here, I should say, is technical, which means you don't belong anywhere. So if I do another set of hyperparameters, I have lots of tweets that actually are just kind of off in space. And so they're not conversations at all. But so now I have what I assume are groups of tweets that are all similar. How do I get pulling out of that? So basically, I assume that in a given conversation, I have a list of partisans. I'm running out of time, so I won't explain how I got them, but I got partisans. And I say, okay, I assume that if the partisans in a conversation are a majority of one single party, that's probably a conversation that is beneficial, that's pro that party, because otherwise why would the partisans be using that language? And then from that, I can then say, okay, I'll use the magnitude of that conversation. I kind of add it together over time, and that gives me something like kind of a change over time. Now, this is just, I'm starting from zero. I'm only giving kind of the delta over time of this. But if I compare this to the actual polling, it matches very well, or I think it does anyways. You actually see very specifically like this kind of moment when the liberals go down, the conservatives go up, and then kind of back again. And what's interesting, and I'm showing this on, there's a background of polls. So the line is our data, and this kind of dotted line is like kind of the average of the polls. You see that actually we're seeing this change before before basically any public polls are seeing it. And if I look at why, so now I have tweets, I can actually see like, okay, what was inside of these tweets that caused this change? Well, this is basically all the biggest conversations I'm showing over here. And the relevant ones are kind of over here. And they're basically all about Trudeau calling the election. There are a bunch of people saying like, why did Trudeau call this election? Everyone knows this was purely political motivated election. There was no reason, and they were actually angry at Trudeau for this. And I think people suspected that this was like, they knew people were angry, but the conventional wisdom was like, it didn't matter that much, right? People would forget about it. But we're seeing that that's in fact the issue that was kind of causing this change. Just one more point, you'll notice at the end, we actually start to diverge, right? We actually see this going up to the Liberals and going down to the Conservatives that wasn't really manifested in public polling or in the results of the election. So there's an open question as to whether, just near an election, something like Twitter is behaving differently, right? And so that we have to take that into account. Or again, here we were seeing things ahead of public polling. So who knows, maybe we were seeing an effect that would only be manifested if the election was a week later, maybe we would have seen this, but this is something that still needs more research. But anyways, I've run out of time, so I'm going to stop right there.
Thank you very much. Thank you. Again, any questions to Shannon?
I have a question. So how do you deal with bots or fake accounts and those tweets that are politically, they have an agenda or someone paid someone to write those tweets, or it's the same person tweeting from multiple accounts, or it's a bot? Like, how do you deal with those tweets in the mix?
Yeah, I mean, that's always a problem. So I mentioned briefly, like we have a sample. And so a lot of the way we kind of lower the chance of getting those kind of things is the way we create our sample on the network, use this thing called conditional independence coupling. Is doing a network sample generally gives us kind of less bots in our sample than we would normally have, because it's based on the connections you have. And generally a bot doesn't have the kind of connections that are making them likely to end up in our sample. But I should say it's not perfect. So there's still some of that. The other thing is whenever I use magnitudes, always the magnitudes of numbers of users, not number of posts, which is another good way to kind of deal with that, because there definitely are bots that just spam a lot of posts. And so at least if you only count the bot once, that's better. Although ideally you're not counting them at all. And the other thing is, notice since we're kind of classifying conversations, theoretically, if a bot is just spewing into the nothing, right, and no one's saying the same thing again, then that bot would be with one of these dots that isn't in the conversation, would not matter. On the other hand, if the bot is saying something, but actually a bunch of people then latch onto it, like that is actually valid opinion, right? Maybe it was started by a bot, but then enough other people start parroting what the bot says because it's kind of working, then we should count that, right? I mean, it's not ideal, but like I'm agnostic as to whether like it was a nefarious agent who caused this change in the election or not, right? I just want to measure it. So those are, I guess, yeah, some of the ways we try to deal with it, but again, of course, not perfect. It's always a hard problem with these things.
Thank you.
Yep, thank you. Another related question is other foreign state influence, right? Do you see any of those? Let's say, because let's say from the Chinese government, we know that they are actually hiring human bots. They are not AI bots. I think people call them 5 cents, because every time when they make a tweet, they receive 5 cents.
Okay.
Yeah, so they are those human bots. They actually try to say something that makes sense, right? But they collectively do it together at the same time to boost up that topic or to boost up a specific post, right? So, do you see any of this happening, or this is out of the scope of these predictions?
Yeah, I was just saying, get it out of this. Yeah, so again, hopefully we should be less likely to have that kind of thing in our sample, because again, we only get you right if you have enough connections with kind of real people. But yeah, no, I don't think in this election we didn't see anything particularly reminiscent of specific targeted foreign attacks, but we weren't specifically looking for it either. So
yeah. Okay, good. Okay, Richard, you have a question? Yeah.
Yes. Hi, Shannon. My question is about the generality of the method. It seems to work well on the 2021 federal election, but as you pointed out, there have been other systems that worked well in one election, but then didn't generalize. And to be fair, the 2021 election is not the most interesting election we've ever had. So have you tried maybe on the 2019 election or on the provincial election, maybe on the Ontario election you just had, applying this in real time to predict the fairly easy to predict outcome of that election?
Yeah, no, that's a good question. Well, I did run a model on the Ontario election, but I was a bad researcher and ran actually a totally different model because I was curious about something else. Yeah, and so no, I 100% agree. So that's something that is a future work, is to try to take some of the, because there's various elections that we've done, and I've kind of done kind of slightly different methods. And future work is to kind of try to, now that we have I have a set of data of numerous Canadian elections, I do plan to, try these methods on all of them, because you're totally right. Elections are very unique and different. And so it's very, I would never claim that because it worked here, right, that I really think it's definitely going to work everywhere else. And a future work is to do a meta-analysis of comparing these methods across numbers of elections to see, what actually does work in a general way. Yeah, no, very valid and important point.
And as a side note, with maybe a very Canadian issue, is that our second biggest province, and one that plays a major role in picking the winner of the election, does not speak English, speaks mostly French. So did you take that into account in your model?
Yeah, not specifically, in the sense that, so the method of clustering should still work in French, but I'm not sure if, like, it would cluster French tweets in a different cluster for sure, right, than English tweets, because I'm not doing anything special to compare for language, right? So that, what I did see, like, it was very clear that it was clustering French differently, and that's kind of what you'd expect, right? When you create like a bird vector for something in a totally other language, it's probably is going to be kind of far away from other things. So they are taken in, the French tweets are still there and used, but they will be separate. And so I don't know if the same issue is being talked in English and French, it's not going to put them together in any way. And then because the smaller number of French speakers, I may be losing some of that information for sure. It is, right. Yeah, it's a very important point.
Thank you.
Thank you. Any other question? Good. Thank you very much. Thank you, Shane. Thank you very much. Thank you. Yeah. Okay, so Ayesa, so
Sure,
you want to share your screen?
And can you see my screen?
Yep, perfect. Good.
Okay. So my name is Aisha Khadir. Good afternoon, everyone. I hope you're having a really nice day and having a really nice conference. I'm the last presentation for the day. This paper has been co-authored by Dr. Faize and Son from Ryerson University, now known as Toronto Metropolitan University, and Hamid Sajjadi from the Ferdowsi University of Mashhad in Iran. And the paper is known as Contextual Query Expansion for Conducting Technology-Assisted Biomedical Reviews. So the main goal of this paper is to contribute to the field of technology-assisted reviews. And primarily, our goal is to contribute to the spectrum of query expansion. So basically, when you have a base query or an original query, what you want to do is add query terms to it, add expansion terms to it to enrich the query. So you get a better retrieval performance and you get documents that are more relevant. In our case in particular, we were looking for documents that are more biomedically relevant. So if you have two documents, one from a fashion article and one from the Journal of Science, I would expect that the Journal of Science is ranked much higher, even though the fashion magazine journal is most probably read way more times than the Journal of Science. So let's talk about how we did this. We did this based on a BERT framework. And for those of you who know how BERT works, this might be kind of redundant, but the way BERT works for people who want to know more is it masks certain terms into a sentence, and it aims to understand the total sentence using contextual understanding. So for example, if the base query is animal models of COVID-19, what it'll do is one part of BERT will try to mask one of the terms. So in this case, the term that's masked is animals. And in the second case, the term that's masked is models. And then what it will do is, using its own understanding of the words and using its own understanding of the entire sentence, it will try to generate a probability matrix and try to understand what word would best be suited for those words. So in this case, what it'll do is it'll say, in terms of this whole sentence, I think the words primate and variance are good contenders for candidate terms. So what it will do is pick these two words and append it at the end of the original query. So instead of having animal models of COVID-19, what we would query with is the expanded term. So we would query with animal models of COVID-19 primate variants. And what this would do is using those two terms, it will retrieve more relevant search. And in our context, it will retrieve more biomedically relevant topics. So our model is known as the BERT query expansion model, or the Bqe model. And as I mentioned earlier, the purpose of this model is basically fine-tuning BERT to retrieve more biomedically relevant search results and to enrich the original query with expansion terms that retrieve a better search performance. Another thing that's really important when you do stuff like this is named entity recognition. This is because sometimes if you do not do named entity recognition, what will happen is the context of the query that's expanded will drift away from the original intention of the user. So for example, named entities are nouns, people, places, etc. A good example of this is this query right here. So the base query or the original query was coronavirus statistics in the United States. If this is the query we're trying to expand it, one of the expanded queries we received was coronavirus hospitalization statistics in the US, which is a good query. This actually results in improved performance, improved biomedical retrieval. The next query received is coronavirus death statistics in the US, which is also a good query to receive because it also improves the search performance. But another query we received before we did the named entity recognition is coronavirus statistics in the United States, Africa. Now this drifts from the intention of the original query. Now, instead of just getting statistics in the US, you're getting statistics from Africa too. It might be important for someone who's searching particularly for Africa, but in case of you as a searcher for United States statistics, this actually drifts from the original intention. It actually gives you more irrelevant data. It actually adds jargon to your data and gives you a worse performance. So what you would do is you would have named entities and you would try to not expand those named entities. And the goal of this paper as it is to assist in technology-assisted reviews. So another thing that we do is we apply a POS trigger, which results as only nouns, adjectives, adverbs, and verbs being included in the final list of candidate terms for expansion. So the next model that we applied is known as the Bqe Ltr model. Ltr stands for learning to rank. So we employed a pairwise approach for our learning to rank model. When we got an initial list from the BERT model, what we wanted was to rank those words in terms of their relevance. So if we got, say, 150 words from BERT, what we would rather have is the top 2 or top 5 words that would actually retrieve more relevant results. If we added all 150 terms to the initial query, we would actually get really bad results. So we want only those that add value. So the neural structure of the LTR model is basically, it takes in the contextual embeddings from the query terms and the candidate terms generated by BERT. It feeds it to a bidirectional RNN. And then this bidirectional RNN has the last layer, which is the forward and backwards layers, which models the sequential dependencies between the query terms and the candidate terms. And this is fed to a set of linear layers, which then generates the score. The score is then used to rank the different contextual terms. Now, this is a little bit hard to understand when you just talk about it. It's easier to show in an example. So here is a good example of the learning to rank model. So our original query, or the base query in this case, is impacts of mass on coronavirus transmissions, which is our query number 1. You see a bunch of different colors here, and I'll explain why. So this original query is fed into the BERT query, and the yellow terms basically are the terms that are used to expand the mass terms for the word impacts. So in case of impacts, BERT said, for example, the words use, effect, and control would be good words to put in terms of impacts. In terms of mass, for example, the red term, transmission, is a good term. And similarly for transmissions, we have words like diseases, virus, all the way to spread. Now, as you can see, just from the word impacts, we got 55 terms. From the word mass, we also got 1 term. From transmissions, we got 110 terms. If I take a combination of all of these, that's a lot of terms to add to my base query. So instead of taking all of them, I want you to understand which ones are the most relevant to me in terms of biomedical search. So I throw this output into my BERT learning to rank model. And basically what it will do is it will apply a pairwise approach between the query and the candidate terms and rank them in accordance of relevance for search retrieval. So now we see that the top 2 terms are control and mortality, and the last term is disease, which is a good term, but in case of retrieving more relevant searches, it's not helping us too much. So what we will do is we will take the top 2 terms and append it at the end of our base query. So we have impacts of mass on coronavirus transmissions, and then the top two terms, which is control and mortality. So for setting up Bqe, which is the BERT query expansion model, we have fine-tuned our BERT model on the COVID-19 open research dataset, which is the COVID-19 model, which has over 500,000 scholarly articles. For fine-tuning this data, we basically parse the data into four main components, which was the query name, the document name, the abstract of the document, and the relevance. So for this query, is this document relevant or is it irrelevant? So a 0 or 1 value. And then basically what you do is you train the model based on the relevance of the document title versus the query name and the abstract. So we split this data into two parts. So 80% of the data was used for training and 20% was saved back for validation. On the left, you can see the training and validation loss. Google expects BERT to be trained on 2 to 4 epochs, which is the recommended value by Google. We chose to train it on 5 epochs because, as you can see, after the 4 epochs, the training and the validation loss stop to decrease and they start to stabilize. So we trained it on 5 epochs. So the way the learning to rank model was set up was basically it took in all the candidate terms and the expanded terms from the Bqe model, and it learned to rank it using bidirectional GRU. And in order to prevent overfitting, what we did was we added a dropout layer with a probability of 0.5 between the RNN and the feedforward layer. We also added a weight decay with a value of 0.001, and we utilized it to ensure that our model performs better. So our main question was, when we want to know how many candidate terms to append at the end of query, what is a good trade-off? So we don't want to add too many terms that we add too much jargon to our base query. We also don't want to add too less terms, so we don't add important information that could be helpful to us. So what we did is, for finding the optimal number of candidate terms that should be added, we tested values from 1 to 10. So do we add 1 terms? Do we have 10 terms? And the yellow line here is, the yellow line here is trained on precision. The red line here is trained on recall, and the blue line here is trained on average precision. As you can see, for all 3 of these graphs, what happens is when you look at average precision at 100 or recall at 100 or precision at 1000, all the values are performing really well until they hit the number 3. There is a sudden drop when you hit n equals 3. So there's a sudden drop here, there's a sudden drop here, and there's a sudden drop here. So what we understood from this is it will perform well if you have 1 terms or 2 terms that are appended at the end of the query. If you add 3 or more, you might start adding more information to the query that actually drifts it away from the original intention of the query. So we added 2 terms here. And these are the results that we produced. We basically tested our model at recall at 100, recall at 1000, precision at 100 and 1000, and then at the mean average precision. So the first row is the base query or the original query. The second model that we created is based on an encoder decoder model. The third model, which is the BERT query expansion model, is the model that was created without fine-tuning BERT. So we just used BERT as it is. We didn't train it on biomedical data. We saw how it performed. Then we used BioBERT because this was particularly for the biomedical applications. We were like, maybe BioBERT would be better to implement. So we tried that. And then we tried our fine-tuned approach. Then we employed the learning to rank model. The P stands for it's trained to optimize precision. R stands for optimize recall. And H stands for optimize an average of all these metrics. N equals 1 is 1 expansion term, and N equals 2 is 2 expansion terms. And as you can see here, in terms of recall and mean average precision, the bolded terms that perform the best is the BERT query expansion learning to rank model, which optimizes precision. And for precision, the thing that outperform all other models and baselines is the average precision one, which is BERT learning to rank model for precision at 100 and 1000. I know I gave you a lot of information in a really short span of time, and it's also the end of the day, it's the last presentation. So I'd like to stop by summarizing basically everything that I've said. So in this paper, we tried to provide a deep learning approach that aims to expand queries by enriching the query with expansion terms. And the target data set in our case was PubMed, which is a very biomedically relevant database that indexes a lot of biomedical scientific articles. We use fine-tuned BERT to get an initial set of candidate terms for expansion, and we get our candidate terms, and then we rank them using the learning to rank model. we evaluate our COVID-19 data set and we show its effectiveness as compared to baselines. These are a few of the many references that we have used. Thank you so much for your time, and I'd love to answer any questions that you might have.
Thank you. Thank you. It's a very nice presentation.
Thank you.
So any questions? Yeah, do you mind to go to slide 11 again, if possible? Yeah. So,
oh, there's a slide? Yes.
Yeah, slide 11. Yeah, so in here, the mean average precisions, right? The map at 100.
Mm-hmm.
It is 0.001. So I know this is better than other method, but is it a good result?
It is a better result because when you look at it is a better result than the baselines and the original query, which was something that we looked at. It is, in terms of map, it is not a statistically significant result. In terms of recall and position, it is. So if that was the question, I think that is the direct answer. But it is better than the original query, and it is better than some baselines that we have tested out.
Okay. Okay, yeah. So does anyone have any other question? Yeah, go ahead, Shannon.
Sorry, I may just have missed this, but what can you expand on the data used for training this? Like I've never heard of this data set.
Oh, so the training data that we used is the COVID-19 data set. It is a open research data set, and basically it is a data set that was made publicly available to basically enable all the data scientists to work on this article and basically train the different things. And it was initially started as a competition, like a Kaggle competition. And then everyone realized the importance of the data set, and then it became publicly available, and it's also updated on a very regular basis.
So like, is it like for each query, there's like one document that it should get back? Is that the idea, or is it?
So there is a list of, I think, 100,000 documents, and then there's a list of 200 queries, and it tells you for each of those queries if this document is relevant or irrelevant.
Okay, so for each query, there's like a bunch of documents that it should get back, and the rest we assume it shouldn't get back, kind of thing. Oh, cool. Oh, wow. So this is very exciting. Thank you very much. I actually just like texted like your paper to my colleagues. I think it's really cool work.
Oh, thank you so much.
Okay. Thank you. Any other question? Okay, if not, then I think we will conclude these sessions and also conclude this conference. And thank you very much for attending this conference and these sessions. Thank you. Have a nice day. Have a nice weekend. Thank you. Bye.